Telematics is a subject which we teach here in 7th semester of Diploma Electronics to our Polytechnic students. Here we will be discussing about chapter 1 as digital modulation. In your previous semester, you had a subject called as Principle of Communication. There your teacher must have taught you about modulation. Can anyone from your side define modulation for me?
A process of modifying one parameter of carrier wave in accordance to information.
Correct. The modulation is a technique in which any one parameter of a carrier wave is varied in accordance with the information. Now the another question comes in my mind is, why should we go for a modulation? Why we cannot transmit signal as it is? Why the modulation is needed? Again, explanation expected from your side.
When we wish to communicate with large geographic area with visible antenna.
Very correct. The modulation process is required whenever the speaker wanted to address through a longer distance, a larger distance he wanted to achieve. So with the help of modulation, he can transfer his low power signal on a high power carrier. So two things you said are important in modulation. One is a carrier, another one is a message signal, the information which you want to transmit. The carrier could be analog, could be sinusoidal, could be digital pulses, whereas the information similarly can be either a analog or a digital. So any one parameter of a carrier is varied in accordance with a message and then it has been transmitted over a channel. The channel could be of a analog, the channel could be a digital channel. In this equation, you can observe there are two things, one as an amplitude, another one as a phase, that is angle. You all are very well aware about this. The part AC is amplitude and the part which is in the bracket after cosine, that is 2 pi ft plus phi is a
Angle.
angle. Very good. This is carrier and we said that any one part of a carrier waveform is varied. So which part it could be? It could be amplitude, it could be frequency, or it could be phase. This is how you classify the modulation techniques. If you are varying amplitude, you refer it as amplitude modulation. And if you vary angle, then it will be angle modulation. The angle modulation has two parts in it. Which those two parts? One has a frequency, another one has a phase. So it will be frequency modulation or it could be phase modulation. We are having two types of it, either a amplitude modulation or a angular modulation. The angular modulation has frequency modulation and phase modulation. Now at the beginning we said that carrier could be either analog or pulses. If the carrier is analog, that is a continuous wave, then it comes under continuous wave modulation. And if the carrier is pulses, then it will be digital modulation or pulse digital modulation. The pulse digital modulation can further be classified as digital modulation and analog modulation. Now from where this classification has come? Now when we talking about carrier, we said that carrier could be either analog or digital, and now we are talking about digital carrier wave. So similar way, the information could be either analog or digital. If the information is analog, then it will be
analog modulation.
Analog modulation, and if it is digital, then it will be digital modulation. The another name which we have given to digital modulation is pulse code modulation. And for analog modulation, three types are there. Pulse, amplitude modulation, where? Yes, correct. Amplitude is varied. Pulse duration modulation, where the duration of pulse is varied. And last one is pulse position modulation, where the position of the pulse get varied, whereas its time period and frequency remains constant. Now let's move on to the learning of a subject. First is objectives. These are the things which you should know after learning the subject or learning this session. The first one is you should be aware about the principle of digital modulation. Means you should be able to define principle digital modulation. Then the next part is, see there you have learned earlier analog modulation, now you are talking about digital modulation. So you should know the factors that influence choice of a digital modulation over the analog modulations. Then why should you go for a digital modulation? You should be aware about it. So that is the second objective of ours. The next objective is ASK principle. Now afterwards, when we go in deep inside a digital modulation, the first type which comes in front of us is amplitude shift keying. That we call it as ASK. So you should be aware about its principle, or rather you will be able to define ASK. You should know the block diagram and circuit diagram of ASK, and you should be able to explain that block diagram, which includes modulator and demodulator. Many people try to classify modulation techniques. As you have seen in our previous slide, there was one classification according to digital pulses as a carrier and analog as a carrier. Now this is one another classification. Here we are considering both the information as well as the carrier waveform. Now here in the first type you can see that which we referred as analog modulation. We are saying here the information as well as the carrier will be analog. Okay, the analog and analog. So which type of modulation you learn in your previous semester? FM, AM and PM, correct. Amplitude modulation, phase modulation and frequency modulations. So these all are the types of analog modulations which you learn in your previous semester. Now what if we have information as a digital and carrier as analog? So that comes under digital modulation, which our current syllabus content is that itself. Here in our current syllabus we are supposed to learn about digital modulation, where we will be talking about digital information over a analog carrier. So digital information over a analog channel. So this is the principle of digital modulation. Next one is pulse modulation, where we will be having analog signal and the pulses will be digital. So we call it as pulse modulations. This we also cover in our syllabus. And the last one is digital baseband modulation. Some people even refer it as line coding. What happen in line coding? We will be having both the signals, that is information as analog, digital, and the carrier will also be digital. Got it? So analog signal, analog channel, analog modulation, digital information, analog channel, digital modulation, analog signal, digital channel, pulse modulation, and both digital information as well as carrier will be digital baseband modulation. Now let us compare between analog modulation and digital modulation. Why do we prefer analog modulation over digital modulation? Is because the analog modulation requires less bandwidth. Comparatively, it is more accurate. Why does we select digital modulation over the analog modulation? Because digital modulation has multiple advantages over the analog modulation. Irrespective of the disadvantages of large bandwidth and less accuracy, the advantages are more in digital modulation. It has high noise immunity, as the amplitude of the digital has two levels, and its error correction facility can be applied. The data can be encrypted, hence the security is also possible in case of digital modulation. Multiple types of signal conditioning can be easily implemented in digital modulation. All the methods of multiplexing like TDM, time division multiplexing, FDM,
code division multiplexing, FDM, frequency division multiplexing, can be implemented in digital modulation. Multiple signals can be transmitted in digital modulation at high speed. The digital modulation is vastly preferred over analog modulation because of following reasons. In an interference environment, in an fading conditions, and in multipath situations, the digital modulation performs very well as comparing to the analog modulations. The development in technology of digital modulations has made it in such a way that it occupies very less bandwidth. Implementation of a digital modulation is very cost effective and very easy. The complexity of the receiver and the cost of receiver is also been minimized in digital modulation. Modulation, simple to detect, is most attractive. The performance of any modulation scheme is measured by power efficiency, by bandwidth efficiency, power spectral density, and system complexity. Power efficiency. The ability of a modulation technique to preserve the bit error probability of a digital message at low power level is called as power efficiency. The power efficiency can be measured at the input of the receiver for a certain bit error probability, and it can be defined as ratio of the signal energy per bit to noise power spectral density. In digital modulation systems, in order to increase the noise immunity, it is necessary to increase the signal power. So there is a trade-off between the signal power and the bit error probability. Higher the bandwidth efficiency, more data can be transmitted in a given spectrum allocation. The bandwidth efficiency describes ability of a modulation scheme to accommodate data within a limited bandwidth. The third factor which plays very important role in selection procedure of a modulation technique is system complexity. Usually the demodulator is more complex than the modulator. The demodulators can be classified either as coherent demodulator or non-coherent demodulator. The coherent demodulator are those which requires carrier frequency at the receiver side, and hence a carrier oscillator is needed, whereas non-coherent does not require a carrier oscillator. Power efficiency, bandwidth efficiency, and system complexity are the main criteria for choosing a modulation technique. As in our earlier slide, we have defined digital modulation technique in which the carrier is a analog or sinusoidal wave, whereas the information is digital. The information or the modulating wave in digital modulation can be either a binary data or an encoded version of binary data. Different shift keying methods that are used in digital modulation techniques are amplitude shift keying, in which the amplitude of an analog carrier is varied in accordance with the digital input. Frequency shift keying, in which the frequency of an analog carrier is varied according to the digital information, and the third part as phase shift keying, where the phase of a carrier is varied according to digital information. Here in this slide, the waveforms of various digital modulation techniques has been shown. As you can observe that in the first diagram ASK, we used 0 amplitude for binary data 0 and some magnitude of sinusoidal wave has been shown for binary data 1. Whereas in case of PSK, we are using different phases. As you can observe there in the diagram, a 180-degree phase shift has been given for 0 and 1. In case of FSK, in the third diagram, you can observe that where different frequencies has been used to represent 0 and 1. This is the diagram which represent classification of digital modulation scheme. Here the digital modulation scheme is classified in two types as constant envelope and non-constant envelope. In case of constant envelope, the amplitude of a carrier remain constant after modulation, whereas in non-constant envelope, the amplitude of a carrier changes after modulation. The constant envelope are further classified as FSK and PSK. FSK basically involves binary FSK, M-array FSK, MSK and GMSK, whereas PSK has binary PSK, differential PSK, M-array PSK, QPSK, OQPSK and pi by 4 QPSK, whereas the non-constant envelope is classified as ASK and M-array QAM. In case of ASK, on-off keying and M-array ASK are the two types, whereas in M-array QAM, rectangular QAM and circular QAM are their types. The figure depicts the ASK modulator and demodulator. Here, the block diagram of ASK modulator is represented here as ASK generation and the demodulator block diagram is shown here as a envelope detection. In modulation, we are using switch for modulation. The carrier input is applied at the input of a switch, whereas the controlling position of a switch is controlled by digital information. When the digital information is 0, the switch remains in open condition, and when the information becomes 1, the switch closed. So hence, whenever we have input as 0, the output available at the ASK is 0, and whenever the input becomes 1, the carrier is get applied at the output and we get signal at the output. Now for demodulation, we have to have only a rectifier. A rectifier and a low pass filter will serve the purpose of a demodulator and we get back our information. Amplitude is a parameter which highly suffers in transmission. It is highly susceptible to noise and interferences. In ASK, we use two different amplitudes of the carrier frequency to represent binary values 0 and 1, resulting it as more susceptible to noise and inefficient modulation technique. This technique is suggested over voice grade lines operating below 1200 bps. Here in this diagram, we are showing a waveform for ASK modulation. Here you can observe that we have used two different amplitudes to represent 0 and 1. When it is 0, we have used a lower amplitude as compared to the for 1. Now for bitrate and baud rate. Now the bitrate and baud rate are mostly confused thing. When we wanted to define bitrate, bitrate is number of data bits per second. Whereas whenever we wanted to define baud rate, the baud rate is number of symbols per second. So sometimes what happen when we use coding, that time one symbol may consist of number of bits. In that case, the bitrate and baud rate will be different, as it happens in QPSK or 8PSK. Now here for ASK, one signal means 1 bit, so the bitrate and baud rate will be same. The bandwidth is defined as the difference between two frequencies. One frequency is a higher frequency and the another frequency as a lower frequency. And the bandwidth is always represented in keeping center frequency at the center. So here see, to find out bandwidth, we should know about the maximum frequency. The maximum frequency here is Fc plus half of n baud, whereas the minimum frequency is fc minus half of the baud. So when we calculate bandwidth, it will be f max minus f mean. So that will be equal to n baud. Let us summarize. In this module, we have learned principle of digital modulation. The principle of digital modulation says any one parameter, either amplitude, frequency or phase of a carrier wave is varied in accordance with a digital information. Then we have seen the factors that influence choice of digital modulation. Basically, for selecting any modulation, power efficiency, bandwidth efficiency, and system complexity plays important role. So digital modulation has numerous advantages over analog modulation. Then we have seen principle operation of ASK. So as per that principle, the amplitude of a carrier, rather analog carrier, is varied in accordance with the digital information. And then in a block diagram of modulator and demodulator of ASK, we have seen switch as a modulator, electronic switch as a modulator, whereas rectifier along with a filter to be used as a demodulator. If the baud rate of an ASK signal is 1200 bits per second, then what will be its baud rate? Just to remind yourself, the bitrate and baud rate for ASK signal is same, and hence if the bitrate is 1200 bits per second, then the baud rate too will be 1200 bits per second. Move on to the next question. Which type of conversion is the process of changing one of the parameter of an analog carrier over digital information? Digital to analog or digital modulation. Digital to analog conversion is the process of changing one of the parameter of an analog carrier over digital information. The amplitude of an analog carrier is changed with reference to digital information where the frequency and phase remains constant. So in which type of digital modulation it happens? The amplitude changed whereas frequency and phase remain constant. Absolutely correct. It is ASK. So in ASK, that is amplitude shift keying, the amplitude of an analog carrier is changed with reference to digital information, whereas the frequency and phase remains constant. Now moving to the next question. How many number of carrier frequency are used in binary ASK? How many number of carrier frequencies used in binary ASK? Only one. So one number of carrier frequency is used in binary ASK. Move it on to the next category where we will ask you short answered questions. So the question number 1 in this case, define digital modulation with help of block diagram. Move on to the next question. Define amplitude shift keying ASK with help of waveforms. Next in the row, compare analog and digital modulation with respect to few parameters. So next question in the row, write down the 6 factors that strongly suggest preference of digital modulation over analog modulations. 6 factors that strongly suggest preference of digital modulation over an analog modulation. Draw the diagram showing hierarchy of digital modulation. The diagram that depicts hierarchy of digital modulation. Define power efficiency and bandwidth efficiency of communication channel with equation. Define power efficiency and bandwidth efficiency of a communication channel with equation. Last question, structured essay question. Explain the block diagram of amplitude shift keying modulator and write down its advantages and disadvantages.